It is with great joy that I introduce the first keynote speaker for the second day of our symposium. A 30 years veteran, Sami Ben-Romdhane is a vice president and technical fellow for eBay. He's responsible for leading its AI platform and infrastructure architecture. Since taking his role in 2009, he successfully delivered critically challenging technological initiatives. Among them, he developed eBay's first private cloud platform and drove eBay blob storage, real-time infrastructure monitoring, Hadoop automation, and the eBay media platform. Sami is currently responsible for the new eBay technology stack and supporting infrastructure. Prior to eBay, Sami worked for Oracle as Senior Director of Engineering, leading Java application frameworks and tools. Please join me welcoming our keynote speaker, Sami Ben-Romdhane. Thanks a lot, Sami, for being with us and being our first keynote speaker in the second day of the Dearborn Artificial Intelligence Symposium. So we are grateful to have you talk about really a very important topic related to scalability of AI and also ethics of data analysis and so on. So for the participants, please feel free, to ask any questions to Sami. He will answer your questions right away. Please send your questions on the chat box and at any time during his keynote, and he will be happy to answer your questions. Sami, so you can start.
Thank you, Marwan. So today we're going to talk about AI at eBay, and we will focus later on the data governance and during the AI data pipeline building and processing. Let me start by introducing eBay first. I'm sure that it's known, but this year eBay celebrates its 25th year anniversary. eBay has been created 25 years ago, and it was the first marketplace, digital marketplace actually, that pioneer of buying and selling communities on the internet. Next. So there is a lot of misconception about eBay, and I want to share with you some facts. eBay today is 1.5 billion listing on the platform at any time, 182 million buyers and sellers transacting on it, and 81% of items sold on eBay are new. And a lot of people think that that most of what's being sold at eBay is like used, but it's not the case. And 2/3 of eBay packages in the US are delivered within 3 business days or less. Few fun facts about eBay. eBay site sells a watch in the US every 5 seconds, a video game in Germany every 11 seconds, makeup product every 2 seconds, and the tool that's in the UK, and the tool in Australia every 4 seconds. Just to show you the scale at which eBay operates. The other thing I want to tell you is, like, eBay is a full marketplace. eBay doesn't have any inventory. It doesn't manage any warehouses. It's just connect buyer and sellers. And it makes sure that sellers have all the tools they need to operate a business on eBay, and that the buyers have the selection and the deals and the right prices for them to buy from eBay. 80% of what we sell on eBay are new items. 90% of them are fixed price. So the auctions at eBay, which was really known before to be is only 10% of our business. 90% of what we sell is a fixed price. And 71% of eBay's items sold that are sold on eBay ships for free. So let me talk about a little bit AI and the usage of AI. So we started using AI almost 10 years ago at eBay in multiple areas, but now AI touches every facet of our business. From the end-to-end customer journey, AI is there, whether it is for driving consideration, online advertising, image recognition, shopper browsing, personalization, search. We have been actually doing AI in search and for relevance and ranking for a long time. When they transact, the trust at eBay uses AI to help mitigate frauds. We do automatic detection of fake and counterfeit products. We do language translation for item listings. For logistics, we do price guidance for seller. We tell them what is the best price for to list their item at, and we estimate the delivery date, and all of that is based on AI. And then even for post-transaction and customer service, we have AI in the flow of our business operations. So let me now be specific about our AI platform. So AI platform is at the core of all our use cases for whether it's computer vision, NLP, recommending, or economic and logistic. We use our AI platform, and we're going to deep dive today a little bit about. I'm not going to describe exactly what we have today, but I'm going to describe the reference architecture of what we do and how the compliance works in all our data pipelines for AI and the processes around AI. So the AI platform today, it's an end-to-end. So based on our AI infrastructure and our cloud-based, it's based on Kubernetes, we actually offer our developers an end-to-end lifecycle management for the data, the model, and the serving and the deployment of these models on our site. And as you can see here, it starts with workspaces and then all the workflow from moving the data, for testing, for sampling features, for training, all the way to model serving and monitoring. And that's what we're going to deep dive today and talk about our data lifecycle from a conceptual perspective. As you can see, so you have two parts. We have the data lifecycle management in one part, and you have the feature lifecycle management. And around this, we have all our data governance tools. So why I'm talking about data governance here is because it's important that as part of the platform, every single data scientist and engineer at eBay uses the AI platform, eBay AI platform, to do all of these features. So the more we are complete, then the more we have adoption. And then once we have adoption and our engineers are on our platform, we can start having an opportunity to understand exactly what data is being used, where it's being used, how it's being moved from one step to the other. And at that point, we can start understanding the policy that need to be driving these data sets, and we'll be able to audit, to monitor, and to apply even policies. As you can see, the compliance lifecycle management at the bottom, it's all about making sure that we are compliant with our retention obligation, we are compliant with our taxes, payment regulation, and all the policy that we actually store in the metadata repository, about all the policies that we need to be compliant with. And then during the processing of the flow of this data and the feature lifecycle management, then we can understand what policy applies to what data set or to what process, and we can enforce it or alert about it. Of course, security and privacy is a main component of that too. So having an end-to-end lifecycle management within one platform allows us to really understand and make sure that we are compliant with everything, and understand if something is kind of risky or not being considered from a policy's perspective. So talking about the feature lifecycle management, as you can see here, and this is very well known for data scientists and engineers, that's what they do. They discover the data, they look at the features that from that data by exploring and sampling. Then they can, once they found the feature that they want, they create it, they make sure that the data quality is what they want, and then they have to now deploy it, and then feature ops management and the data feedback loop to understand actually if there is any bias, any decay in the data, And that cycle actually tunes itself and goes around and around. And that's how you get to tune your algorithm and your feature while they are served. So from a reference architecture perspective, we go back to the data platform itself and we deep dive in that. So you have the model lifecycle, the data lifecycle, and then your data scientists are interacting using a workspace. And from that workspace, they start actually discovering the data through our tools, and then they will start moving that data around, asking for subsets and train their models. And as they do that, we know exactly the lineage of the data that is being trained from, where is it coming from, the model that was created, how it was managed, how it was, the feature inside there, how they were discovered. And then at any time, we can have a history of everything that happened in here. And so it's auditable, it's observable, and we can apply our governance policy. And there is low risk really of any wrong usage of the data at any time. Even at the consumption, on the consumption part, you can see that the AI platform is the one that deploy and serve public traffic from our services that are exposed to the outside, like view, item, checkout, and all of that. From a future preparation, so this is, you can see in our data science ecosystem, you have the ML engineer or data scientist. Again, from their workspace, they query their data, we assemble the data for them, we query the data and assemble it for them. As we do that, we do the inventory and we keep the tracking what the data is coming from. We do the processing, and if we need to, for example, if there is a policy that the data need to be anonymized or need to be masked, we do that automatically so that there is no risk of anything. The same thing, as that data is being queried, then we know exactly what the data set is. At the runtime, we know the usage of that model on what data and the training that happened on it all the way around. So it's very hard to implement this afterthought. If you start from scratch, that's where you should really think about. But once you start without taking into account the data governance and the compliance, it's very, very hard to add it after that. So you have to think about really how to get to where you move all our processes and all your data extraction in one area, in a central platform that could track and trace the data and make sure it's compliant. And then this is really the most important thing. This is where the machine learning operation and the observability lifecycle. So as we monitor, we can monitor for multiple things. We can monitor for model decay, where the data becomes stale and the model becomes not applicable anymore. We look for bias, algorithmic bias especially. We look for drift, especially when the models start drifting and from where it was supposed to be. And we can alert on when there are outliers, on the data integrity, on the data quality, and then the tracing and explainability is where all that work that was done before is now very useful. At any time, we can verify, we can reproduce, we can understand the transformation that happened, so we can get a better explainability of the results. And that is a very important component of the compliance also. And then, of course, as we do that, we have an analytic component that take all these metrics and make sure that they are valid, and it reports back to the engineers and to the executives who are interested in that part. So talking about the data policy and the classification, as I said, at any time when there is an action from a user to access data or to sample, to do feature sampling or anything like that, since we are on the path, since the platform itself, when we say we, it's the platform, the AI platform is the one doing the action, then it can, at the same time, it has a set of policy it has to be compliant with. So you have a data repository and you have a policy repository and you have a graph that links data sets and the policy that need to be applied on that data set. So as our engineers are extracting data and transforming it and managing it, at any time we know what are the policies that need to be applied on that data. And if that action by the engineers and by the customer is compliant or not. And that's how we categorize and classify every single piece of information. We know that this is private, this is confidential, this is restricted, and then we can apply those policy and make sure we have to transform the data if it needs to be, or not give access to the data if there is need to do so. And you can see that as we do that, even on the storage layer, we have all that metadata information that allow us actually to keep the regulation updated, keep the classification of the data updated, and also the data sets themselves. So this is a complete holistic view of how you can implement data governance and make sure that you are doing the right thing for your customers. Last thing I want to talk about is the concept of differential privacy. As we do data science, do a lot of research, and sometimes they need to partner with third-party universities, for example. So how do we get to advance the state of the art and still being compliant? And that's where the differential privacy concept comes in place, where we do actually, when we share data, we make sure that we understand what the data is, if it's shareable or not as is. If it's not shareable as is, then how can we transform that data to be compliant with, for example, privacy, not to share all what's PII, but at the same time, process the data in a way that can still give us very good results without having to revealing PII information. So that's allow us to at least work with third parties, even though they are not trusted like as an eBay entity, but we can still have that relationship going, and then can get good results from the sharing of that data. So we're not sharing our data as is, but we under contract we can share data while anonymizing and on transforming the data sets, not to reveal the identity, but at the same time keep the same characteristics. And this is kind of how the reference architecture of implementing the differential privacy is. So the same thing, the same flow, as the data is moving in our system and going out, we understand, depending on the data sets and the classification, we can mask it, we can redact it, we can put a noise on it, we can, in order to make sure that we still are compliant while sharing that data. So I know that there is a lot to talk about here, but just this to give you an idea about how an internet scale company, when we had to deal with the regulation and GDPR and all this new, rules that were put on us, and they are very dynamic. The data change, the rules change, the policy change. So if we don't have a system that is automatically take this in consideration, it will be really a lot of trouble and a lot of money being spent, a lot of people to work on this, and still we are not sure if it will minimize the risks. I think this reference architecture is what keep us doing the business, but at the same time ethically correct and safe. So that's it. Thank you very much.
Thank you very much, Sami, for all this great insight. And yesterday, the IBM Chief Data Officer in his keynote, he talked about the role of bias in AI from a different perspective, which is more human related and so on. So it's great that during your keynote today, you talked actually from the architecture perspective and how this is actually get deployed and working in a very scalable, organization like eBay. So I think that the audience already asking you a lot of questions, but let me ask you probably two questions to interact with you about this actually very important topic of dealing with all the governance of data and knowledge organization, including security and so on. So my first question is, what advices or what lessons you want to share with, for instance, students or probably practitioners who want to improve their skills in that side? Because AI is always seen as more nowadays interdisciplinary field where you talked, for example, about security issues, about other type of compliance, legal, and so on. So how they could be ready actually to satisfy organization like eBay and beyond with their skills in this.
Very good question. You know, even for eBay, it was a journey for us because as the regulations started to harden and change, we were caught like, you know, as like anybody else, and we found that we had to go and review our stand, because like 5-6 years ago, it was all about using the data, democratization of the data, make the data available to anyone who can use that. So the more it's about the business opportunities. While even, I mean, at the time, the most important compliance, and not even compliance, but making sure that to secure the data. That's one, number one, is making sure the data is secure, that there is perimeter security, that the data is encrypted when it's coming for credit card data, PCI, and all that stuff. But then as regulation, especially in Europe, and GDPR started to be in place, we were caught a little bit because we have, you know, we have thousands of applications. We have at 800 petabyte of data that is in there. So how do we go? And then the data is not like source of truth, because there is a data that we ingest in the beginning and we acquire, and then it gets transformed, and then it gets denormalized, and then get pushed to data warehouse, it get pushed to Hadoop. People use it, transform it, put it back somewhere else. And then how do we trace all that data? So it took us like 2 years to go and at least establish that first step, where we need to go and do the full inventory and start putting the processes in place. And that's where regulation technology is now becoming, the technology to use because of the scale. But I mean, for students and for for people who are new to this, every time you are using data, every time you are processing data or transforming or migrating data, look at the data and think about the compliance. Am I allowed to take this data and put it on my notebook and do some experimentation with it? You know, the question, the answer to that sometimes is no, you cannot. So sometimes we are not really, it's not we are not thinking, it's just not natural in the beginning. But once you start always asking yourself the question, what is the classification of this data? Do I need to have it here? Am I allowed to use it in this use case? And then as you start asking the question, then you start becoming now understanding more the classification of the data, the compliance that you need to be, respecting, and all of that. So it's very important first to start asking yourself, and then everything else will follow.
Yeah, great. So the second question quickly is more about all the different components that you showed in the current architecture of dealing with AI at eBay. So we all know that most of these problems in general, they're treated in an isolated way, I would say, and it may create some consistencies, issues, and so on. So as you mentioned, it's probably a long journey. So what's your vision around, having more holistic, framework from A to Z that can take everything from the beginning, like doing data sanitization, cleaning, and providing explainability, support, and so on, as a whole pipeline, probably as you showed, but it could be more comprehensive to different departments and the companies, because sometimes we may see some inconsistencies. So looking to that generic view, I would say, about this type of architectures, what's your vision around this, and what are your insights about making this even more generic to other companies as well?
Yeah, so I think there is a good, especially for machine learning and AI, there is a very good pattern, is that most of the data scientists and most of the ML engineers, when they interact with anything, they start with, and we were lucky because there is a lot of tools, but when you talk about notebook, for example, Jupyter and notebooks, that's where it starts. So if you give your developers a good developer environment that allow them, and that's what we did at eBay, using a DSL language to go and extract data and transform it using the Python libraries, then for them it's natural. I want to use this, right? Because I can It shows me all the data that's available for me, all the models that are available for me, the different version of the models that are in there. I can bring data, I can ask the system to go and they really process this data this way, transform it and bring it to me. And this is the sample I want. So at that point, actually, you are not, the developer isn't, the incentive is not to use those backends. You don't even know about those backends. The incentive is the ease of use. Okay, oh, we have all these data sets. You show me all these data sets. This is all your data sets. You can deep dive in those data sets, where they are being used, what kind of model we've been trained with this data. And then as you do that, you can take it from there, and then start using the system. And as you are using the system, that's how the backend start actually making you compliant without even you knowing in the beginning, or it will alert you. It will tell you, oh, this is, a privacy concern here. You're using data that should not be, should be masked or should be anonymized before you can use it. And that's how it starts. But we are lucky that there is not a lot of developer environment for AI and ML. I mean, most of them start with using notebooks and things like that. And that tool becomes so popular that now we can start, and then it has an ecosystem that it can be plugged behind it. And that's what we did.
Great. Thank you so much, Sami, for really this insightful keynote and all this great advices and also vision about AI. Especially, I mean, really enjoyed. I mean, you showed how this is actually work in practice in really very big